Hello everyone. In this video we're going to quickly talk about what some people call the limit theorem, and what some people might find the much easier way to discuss how two functions relate in terms of their asymptotic complexity. So, what we're going to do is take our two functions we care about, f of n and g of n, and divide them, and find out what happens as we take n to infinity. This makes a lot of sense considering our definition, because in our definition, what we were saying is that for large values of n, bigger than n naught, what happens? So the limit is a very natural way to extend that idea. So, if we evaluate that limit and we get 0, that tells us that the numerator and the denominator relate in a specific way. In this case, the denominator is growing much, much faster. So the numerator would be bounded above by the denominator. Or, in our new notation, f of n is in big O of g of n. And in fact, what happens is that it's growing so much faster that it would not be in omega of g of n. Similarly, if we flip everything around and we get infinity for that limit, we have it that the numerator is growing much, much faster than the denominator. So the faster growing function is f of n, which means that f of n would be bounded below by g of n, or f of n is in big omega of g of n. And again, it also means that f of n is not in big O of g of n. If you evaluate the limit and get literally anything that's not 0 or infinity, it needs to be positive, then the functions are growing at roughly the same rate. Neither one dominates the other as we're going out towards infinity. In that case, we get that they are in theta of each other. This is convenient because you don't need to have some intuition about how they relate ahead of time. You can evaluate the limit and see where that leads you.